Okay, so for this geometry, can you determine the angle between the pole and the cable? So basically, angle between the pole of the cable or the angle between the two cables. So that's the angle between the two axes. So it's relatively very simple. So I'll go through. I guess you may have covered this in your college, but let me explain it. So the dot product of two vectors A, B is defined as the product of the magnitude and the cosine angle between them. That's here. That's the dot product. Excuse me. Excuse me. Okay. So, so the dot product of two vectors A and B joining together at one end, if you want to find the dot product, it is basically the magnitude and the angle, cos angle between them. That's how you will be able to find the angle between the two vectors. Now, it says here the angle is the smallest between the two. That is basically it ranges from 0 to 180 naturally. Okay, so dot product. The result of the dot product is a scalar, could be a positive or negative. The units of the dot product will be the product of the units of A and B vectors as usual. So let's look at this in more detail. So dot product of A dot B is this. How we found this? Do I have it here? Yes, I've had it here. Yes. So the dot product of two vectors. Let me change the color. That's not appropriate. Go for. Come on, give me a choice. Okay, so the dot product of two vectors, this is bold, so it's in vector form. So I can write it like this also. The dot product of two vectors is this. In simple words, y. We've got two vectors A and B. That's vector A here, and this is the vector B here. They both are written in the Cartesian vector form, which is given here. And for this one is here. Okay, so they are in the I, J, and K form. So if I do A dot B, so I multiply first this one with this one. So that is basically AXI into BXI. Then I multiply AX with my BY. That would be plus AXI into BYJ. And then same as, oh, sorry, come on. Sorry, apologies. And same as plus AXI into BZK. That's the first, and then I can do for the same for AY and AZ. The one that I want you to concentrate is on this one. So that's basically I dot I is equal to 0 because the angle between my two lines is 0. Both are in the same direction. So the cos of 0 is 1, whereas because I and J, they are at 90 degree, I, J, K, they all are at 90 degree to each other. So cos of 90 is 0. So therefore, this term, this term and this term becomes 0, where this term becomes this. And same for the other two components. So in simple words, remember your A dot B, and let me get rid of this now. So my A dot B is equal to the multiplication of X components plus the multiplication of Y and the multiplication of Z component. You add them together and it is explained here. Okay, so let's move on. So A dot B, this is what you have to remember. And A dot B, this is the other part you have to remember. So A dot B you can get in two ways. Either you can get it in this way, or you can get it through magnitude also. I can combine those two together. That is basically in simple words, what I can write is this part is equal to this part. I can even do that. So for the given two vectors in the Cartesian form, one can find the angle. That is basically, so for the given two vectors in the Cartesian form, one can find the angle by finding the dot product, that's here, finding the magnitude, and using the definition of dot product, that is here. As I said, I can combine this part equal to this part, this part, and that's how I can get my angle out. Okay, so you can determine the component. So that was the angle. Is there any issue with the angle? Is that clear to everyone?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir. Yes, sir.
Okay, so now let's look at the other thing. It says here you can determine the component of the vector parallel and perpendicular to the line using the dot product provided the direction of the line is defined by the unit vector. So basically what it is saying that if you know this vector, you can find its component parallel to the axis of which you know the unit vector by getting this out. I've written it somewhere. Let me show you. Is it here? Yes, yes. So, okay. So basically what it's saying here is, if you concentrate on this part here, what it's saying is that the A component, which is basically given here, that's the axis, that's the A axis. So the A component of my vector A is equal to A cos theta, and this is also equal to this part because my A dot A unit vector is equal to the magnitude of A and the magnitude of UA, which is basically 1. Sorry. Come on. Oh, what happened? Sorry, apologies. Let me explain it again. Come on, work. Okay, changed. Come on. Oh, come on. Why it's not working? Okay.
It won't work because you have saved the annotation on the
Did
slides.
I? Okay. Apologies. Okay, let me explain it again. So I'm doing dot product of the vector A, that is this vector A, and the unit vector of my axis A. So I've got my A here. I've got my unit vector A, which is in the direction of A axis. So the answer would be the magnitude of A, the magnitude of unit vector, which is 1, into cos of angle. By taking the dot product of vector with the unit vector along the axis, you can find the angle and also the A component of the vector A or the X component. This makes a bit, because what they've done is they've got the vector A given and they've written the X is A also. This should be X so that there's no confusion. I saved it, so made a blunder here. So this is my x-axis, okay? This is my x-axis. So if I do A vector dot x, so unit of x vector, my answer would be the magnitude of A, the magnitude of unit vector x, which is 1, multiplied by the cos angle. So this becomes A cos of angle theta. And this is also as the x component of my, the x component of my vector A. Is that clear? So in simple words, remember, if you do a dot product of the vector along any axis, you can find its component on that axis. Let me explain it again. If you do the dot product of a vector with the unit vector along the axis, if I do it along I unit vector, I will get the x component of it. If I do it along the y, so along the j unit vector, I will get its component along j. So that's how they do it. And once you found the x component using Pythagoras theorem or common sense, you can find the other component, which is basically given here, or subtraction of vectors. You got this vector here, you do minus this is plus, so minus would be in the other direction, and then you get your resultant out, and this what is basically given here. That what I've explained. Adding two vectors, you can get your perpendicular out, or this is more like a Pythagoras theorem given here. So you can use both. So is that clear to everyone? So remember, in simple words, if I want to find the projection of, so if I have to find the projection of a vector along any one axis, I need to do a dot product of that vector with the unit vector along that axis. Is that clear to everyone?
Yes, sir.
सर एक्सक्यूज मी सर
Yes.
सर जो हमारा आपने कहा यूनिट वेक्टर, वो यूनिट वेक्टर उस वेक्टर की प्रोजेक्शन का यूनिट वेक्टर होगा ना?
Yes. Yes. Yes.
यस सर, ओके.
So basically, it's basically a unit vector. So that there's no confusion, let me show you another thing. This is another axis. Sorry, this is another axis. I'm making y dash. This is a y axis. I want to find the y dash component of my A. So what I would need my vector A dot the unit vector of my y dash. So unit vector, and that will give me my A cos of theta, and this theta, sorry, I'll change this. This is phi, so that's my phi angle. Is that clear now to everyone?
Yes, sir.
Okay. So directions, unit vector, very important.